is often involved both in when you do text mining or when you do content analysis. Content analysis being an approach where you have a dictionary like that. But a lot of technique used in text mining are based on what we call bag of words approach, and those techniques actually do not allow any disambiguation, which could cause some problems. That's the reason why a content analysis approach is often better, because it allows you to sometime not only well, measure concepts, but try to disambiguate some words that will have several different meanings. So this is an example of some dictionaries that have been created where we put some words or some phrases in order to measure some concepts. And typically, one thing that you need to know is that actually phrases are less prone to being ambiguous. But if you take a single word, quite often they may have many different meanings. Just let's look, for example, at the leadership category. We only have phrases, but if we had words, and let me show you that actually the word leads actually have several meaning, both as a verb and as a noun. You could have many different meanings, and many of them may not be related at all to what you are trying to do. And I will give you some ideas, and I will at some point jump to WordStat to show you how this is done in WordStat if needed. So I did already mention that there are three major obstacles when you are doing text analysis. One is the very large number of words. So a single corpus could contain tens of thousands of word forms or terms. The polymorphy of language. This is what the dictionary helps you to deal with by grouping words that are synonyms that mean the same thing. But the challenge that I want to focus today is the polysemy of words, is the fact that a single word can have many different meanings. If you are only adding phrases to dictionaries, it may not be as problematic. But if you had words, typically each word will have many different meanings. Now, let me give you an example. We did, and actually, if I will jump back to WordStat, because I will actually show to you live. Okay, so we have, I will apply a dictionary. This is the Luke dictionary, but there are several dictionaries based on words, so it's not the only one. But the Luke dictionary has many different categories to measure different concepts. For example, for family, we have all of those, and they are not only words, but word roots with wildcard at the end to take everything that starts with that. And we have several emotion, things like that, but we also have a sexual dictionary that has several words. And if I applied this dictionary from my data sets, and let me do it this way, if I will select actually I will select the psychological process, I will get some frequency. And typically people will then jump right away to maybe do some comparison and come up with some outcome like that. But if I look at sexual and I'm trying to compute and compare candidates, I could come up with some conclusion about, okay, Romney seems to have more reference to sexuality than Kucinich or other one. But the thing is that when you apply any dictionary, especially when you do that with a dictionary that is based on words, you have to check to make sure that they are accurate and that you are actually measuring what you want to measure. And if let me go back to my PowerPoint. Okay. Okay. If I look on my data sets of political speeches, I found that there's actually a lot of false positive, a lot of words that are being mentioned that are actually not necessarily relevant. AIDS, for example, associated with band-aids in 2 cases. In most cases it was okay, but in 2 cases it was not good. Bi, like in bipartisan, was actually in the dictionary to make reference to bisexual, but actually in none of those cases it was associated with that. It was more associated with bipartisan. And Dick Cheney, of course, was scoring I, or Dick Lugar on I on the sexual scale, as well as other things like Virginia, etc., etc. So here we have a problem of ambiguity of words, and the problem is even worse when you have word roots like that, because you could actually catch things that you didn't expect to catch. Now, there's a few ways to deal with that, and let me actually go back to the actually, if I will show you the basic principle how you deal with that. What you need to do is that you need to do a keyword in context. So the keyword in context will actually show you how each word of a category is being used in a corpus, so that you'll be able to do that. And it's quite easy from almost everywhere. In WordStat, I will take the sexual and I do a keyword in context, and it will actually list all the words. And now I have quite a lot of words, and they are actually sorted here by the keywords and before, or keywords and after. And this is what will allow me, for example, to find that for Dick, it is followed by Dick Cheney most of the time, or Dick Lugard, or someone else. Okay. So the keyword in context is a crucial feature of any text analysis software. Now, okay, let me jump back to the PowerPoint. Okay, I have to do some transitions here. So the keyword in context will allow you to not only identify cases where a word has a different meaning than what you're looking for, but also find maybe ways to disambiguate it. And let me show you some examples. So here is an example of where we try to measure emotional stress from incident reports from an airline company. So we try to measure emotional stress, but stress has 3 different meanings. First, it could make reference to a state of mental or emotional strain. This is actually what we try to measure, but it could also be used to make reference to force that produce strain on the physical body, like the wind on a windshield, or any object that would hit a physical part of the airplane. But also, and the most important one, is that it could also be a verb that means singled out as important, like some of the examples that we can see here. I had to make a second PA announcement to stress the need for all passengers to take their seats. So, and we've actually found that most of the time the word stress, or variation of the word stress, like stressed here, were actually associated with this verb. But if we want to measure emotional stress, those would represent a false positive, and we need to get rid of those. How can we get rid of those? Well, the first way to do it is to look for phrases, and that's the reason why the keyword in context could be sorted on the words and what's come after, or the words and what's come before. The reason is that it will allow you to maybe find some phrases, some sequence of words that would allow you to disambiguate that. So in our cases, we found that when stress was followed by the or that, it was almost always, if not always, associated with the verb, so that we could actually tell the software to ignore those. Now, I could also look for keywords and before, and in this case, we found that under stress, or their stress, were actually all instances where they were making reference to the emotional states. Now, you could imagine maybe some phrases that where you could have a stress making reference to the verb and have under before, but it while you can imagine that, it may not be relevant because in the data sets you are trying to analyze, maybe nobody will do that. So you really have to look at how people use that. Don't look at possible ways if it could be wrong. You have to look at how in your data sets that kind of data is being used. And that kind of word is being used so that you could actually come up with some rules. Now, there's a few problems, however, if you want to disambiguate. Well, many software that will that will do content analysis will actually do that by matching any item. So if you have stress, it will match it. If you have stress, it will match it also. And this is a problem because you cannot actually use those sequence of phrases to actually disambiguate the words and only measure it when it is relevant. The only way would be to maybe pre-process it and change all stress that to a single word, so that you would or do that kind of pre-processing in order to be able to get rid of those false positive. So if it's pretty difficult to disambiguate. Also, some people, some software will actually create a list and sort this list in order to speed up the content analysis process. But then if you simply match the first one that occurs in a list, it's problematic because actually stress will appear likely before stress or stress that, or there may be some phrases that could be relevant to disambiguate that may appear after the first item is being encountered, the target word is being encountered. So there are better ways to do that, and if the content analysis tool that you have don't have that, then there's no way for you to deal with that. But if, for example, there's a possibility to actually carefully arrange a list so that the disambiguating items will appear at the top, or you put that into an exclusion list somehow to get rid of those before it is being processed, the single word is being looked for, then it may be possible to do that. The way WordStat works is this way. We try to, when we analyze the text, we give always precedence to longer phrases over shorter phrases. So if you have a phrase that have 5 words, a sequence of 5 words, and there's another one that overlap it but only have 3 words, then the software will always take the longest phrase. The reason is that the longer the phrase, the more specific it is. Like healthcare is a 2-word phrase, but healthcare cost is a 3-word phrase, and this concept is more specific than the healthcare, the 2 words version, okay? Also, we give precedence to phrases over words. So when a word is part of a phrase, the word will be categorized along with, the phrase will be categorized, but the words in it will not be categorized if they appear elsewhere. And some people think that, would prefer to have the ability to actually count the word even if it's alone. But if you allow that, then you are no longer able to disambiguate meanings of a single word. Also, in WordStat, words also have precedence over word patterns and longer word patterns over shorter ones. So if a word if a word pattern contains 5 letters and the other one that overlaps only contains 3 letters, the one with 5 letters will actually get precedence over the other one, okay? So those are the matching rules that allow you to come and disambiguate things. And the way it works, and let me go back first to WordStat, okay? The way it works is that when you are actually, when you build a dictionary, what you have to do, okay, let me go back and do the keyword retrieval, keyword in context, and I will show you how typically this is done in WordStat. I will get the keyword in context, but I believe it is in a different screen. Let me bring it back. Okay, it's here. Okay, so when I find a phrase that needs to be disambiguate, for example, dick, I want to put it somewhere. What I could do is I could select it from here. So I found those, I sort out on keyword in after, I find that Dick Cheney should be put somewhere else. What I can do is I can actually right click and add it either to the exclusion list or to a categorization dictionary. But actually I have my dictionary. So I don't have any category where I can put that, but what I will do is and what I often do is a to be ignored category or a disambiguation category that I will create in my dictionary, so that every time the software will find Dick Cheney, if it will no longer categorize that as a sexual, and I go on like that, and I may look at some other ones, like there was quite a lot about Virginia, for example. Virginia, let me add that to my exclusion list. Okay, so now if I close that, and if I simply look at the frequency, sexual was 502. Sorry, I have to reapply my dictionary. Yeah, I have to select my category to be ignored. So it goes from 502, and it should go down to 422. So I just remove about 80 cases, false positive cases, and by this way I have a more precise measurement of the sexual category. Now, when you disambiguate, okay, you could when you develop a dictionary, you need somehow at some point to validate the dictionary, and one of the things is to look at whether you have true positive or false positive. Sorry, and typically what you can do is you could actually use some rules, and you have to do that for every item in your dictionary. And what you need to do is that you have to make sure that every single item in the dictionary produce a certain criteria of true positive. You have to accept the fact that in some cases it may not be possible to disambiguate some words, or you may have some noises, some single item that occur at a very low frequency, but the rules that was actually proposed by those two authors, Bengtson and Xu, was that every single item in the dictionary should put for the dictionary, meaning a category in your dictionary, should produce at least 80% true positive. So typically what you should do is that, okay, you develop a dictionary, or you use an existing dictionary, you apply that on your text before drawing any conclusion. You have to validate whether you have this 80% true positive for all items. So you go to dictionary, do keyword in context. You can do that on a random sample if you want, and typically you assess whether every item gives you true positive, and how many of them are false positive. And the rule is that if you can, just like I did, you try to remove false positive using associated phrases, just like I did when I put the Cheney and Virginia in the to be ignored category. I was able to reduce the number of false positive, and at some point I may be able to reach this 80% true positive. So I do that for every word. But if a word gives too many true positive and I cannot bring it down, actually I should probably consider removing it. But if you remove it, maybe there are some few cases where you could add some phrases associated with that. And let me give you an example. We have a money dictionary. Let me sort that this way so that I could, it's not there. So let me go back here. I will bring it back, it's here. And I will do it this way. Okay, so I will focus on a single category, and I will show you an example where a word may be problematic. So the money dictionary from the Luke, I do a keyword in context on that. We have about 12,000 hits, and it will take a few seconds. Okay, now the software found me all the items, and I could look at some of those and find that, okay, they are okay. But I know that if I look at the word bill and I sort on keyword and after, I will actually see that there are some phrases like Bill Clinton and Bill of Rights, okay? But actually, even if I remove those, I found that most of the time when they talk about bill, they are not talking about a reference to money. They are actually making reference to a legislative project that they try to pass finish in it. So again, we found that the word bill, no matter what we do, we still have more than 80%. So what I would do is I would go back to the dictionary, remove the word bill, then try to look at whether there are some phrases that may be good. So for example, I may think that if I do a keyword and before, I may think that credit card bill or pay my bill would be good cases, and so that I could actually at least had those. So I removed the words, but I had the phrases that are positive. But actually, what we did found is that even credit card bill or electricity bill was actually associated with legislation project. Okay, so it's not they were not appropriate. But pay my bill, and do I have something about pay their bill? Let me see whether I can find some of those. State that bill, sign that bill, veto that bill. You see that most of them are not correct. This bill, you get a lower utility bill. Okay, so that would be one. Utility bill, maybe I should keep that, so I simply select those. And in WordStat, you don't need to select the full words. You simply have to make sure that you overlap the two words, and the software will automatically select both. And then you add that to the money dictionary after removing the word bill. So this is another way to deal, rather than trying to find phrases that are associated with false positive. You are actually removing the words and add the true positive phrases. But again, it's you really have to look into the context, because if I tell you that, okay, credit card bill is associated with money, you may say, of course it is. But when you actually look at the context, and it was the case also for electricity bill, most of the time it was not. Or credit card bill, it was a credit card bill of rights that was there. So this is the cases where even if you think that the phrases will get you out of trouble, it is not necessarily the case. But so you even have to check for phrases. But again, phrases typically less inclined to create false positive. Now this is the criteria proposed by Bengtson and Yu, but again, you have to take that into with grain of salt, because it's the 80% criteria is not necessarily the rule that you should follow. In some cases, you should maybe have a 20% criteria or a 1% criteria if what you want to detect is actually quite important, and the cost of missing one is great. Then maybe you should reduce, and you should accept the fact that you will have a lot of false positive, because what you want to do is detect something that is at low frequency but quite critical, like, I don't know, a terrorist attack, for example. You don't want to miss one, or someone who posts message online, and he say that he will commit suicide. You don't want to miss one if that's what you're looking for, and that's what you try to prevent. So the 80% criteria would not be a good criteria. You should probably have something like a 1% or even a 0.5% criteria, knowing that the software will allow you to reduce the number of hits for those cases, but and bring it to a amount that could be reviewed manually, but you will be sure that you won't miss one, or you'll be not sure, but you have greater chance of not missing one if you accept the fact that that number of false positive will be low. So again, that's a rule of thumb that for most cases would be accurate when you want to describe something, but you have to also to take into account what is your objective and what is the cost associated with false positive or false negative. Okay, and those authors actually wrote a report. They work for the U.S. State Department of Agriculture, and they create a report that is considered to be one of the best document on how to create dictionaries and how to also make sure that they are precise. So this is a good example. Now, phrases are not necessarily good enough. In some cases, it will be difficult simply by using phrases to disambiguate and come up with something that is precise. And when you need to do that, what you could do is start to use rules. And rules are could be somehow slightly more difficult to develop, because it involves doing the keyword in context, but then looking for surrounding words that may be associated with some false positive and or true positive. So, for example, if you're looking for transfer, technology transfer, you could look for transfer is near technology, or transfer is not near bus, and WordStat will allow you actually to have specific criteria. For example, you could actually tell the software that it should look for some words, one or several words, in the same sentence, or in the same paragraph, or in the same document. And I will show you pretty quickly how to build rules in WordStat. Okay. And of course, you could, one thing that you should know is that WordSet will allow you to create more than one rule. You could actually create up to 4 rules for a single word, a target word, but you could also make reference to not only a single word or a word root like here, but also to categories, and categories will be preceded by a number character to indicate that it actually does not refer to a word, but to a categories of words. So now let me show you how to create a dictionary, a rule. Okay, and rule could be tricky because, well, first you have to understand exactly how it works. And let me close that. Okay, and I will try to create some rules. So here we have, let me go. Here we have a dictionary that measures, for example, emotion. And we have something about positive emotion. But I know that if I simply look at those words, I may have some issues, because I may want to, those words could be preceded by some negation, for example. And the problem with negation is that they won't necessarily appear immediately before. Many of them will appear just before, not satisfied. But it could be not very satisfied or not at all satisfied. So it's 1 word, 2 words, or 3 words before. So to create a rule, you have to click Add, click Rules, and then now you have to name the rule. And so I will name it neg-eval for negative evaluation. And what I will do is I will create a rule that will try to measure sentiment, but will take into account the negation. So we have a positive emotion. So here the software will look for any word in the positive emotion, and here we may have several hundred words. And I will tell the software that it should not appear not after a negation, and I could type not or not, but I can simply type not 1 word here, I could also put a phrase, okay, not at all, for example, and again, space will be replaced by underscore character to let you see where they are, okay, but I could then say not after no, not after never. But you imagine that there are many negations that could be used, and again, I would have to select from in the same sentence for each of those, and I will have to tell the software that they will have to match any. So whether a positive emotion, if after any one of those, it will be categorized as a negative evaluation, even if it's positive by itself. But it's pretty tricky to do that. So a better way is to actually tell the software that I want that well, you create a category that will contain all the negation, and I could actually, I think I do have a category here, negation, which contain maybe 30 different words, no, never, few, seldom, etc. And it will look at that within the same sentence. And now the only thing I need to do now is to categorize it. And the thing is that you have to be careful because you cannot categorize it in the positive emotion category because or the negation category, because it actually is part of this category. So you need to store it somewhere else, and because otherwise you will create a kind of vicious circle. The software, in order to evaluate whether the rule is good, we'll have to apply the dictionary, but to really apply the dictionary, if it needs to assess the rule. So it's not possible. So you have to create it elsewhere. And just to give you an example, where we use the rules, we created a basic sentiment dictionary. Again, we have some warning about this dictionary. It should be customized to a specific domain. It has not been customized. It is a general one, a starting point. But what we did is that we listed all the negative words that we could find, all the positive words that we could find, and we look at negation, okay? And you see all of those negation were put there, and you could add some if you find other ones. And the thing is that the software will not measure sentiment with those. Actually, if it will use those, but it will not be the ones that will be used for the final evaluation. It will actually look at some rules, and we actually create two rules that we put in two different folders. We could have put them in a single folder, but if I look at that, it's actually look for a positive words after a negation. So not good, not satisfied would all match this rule, okay? Real bad, if I look at that, it's actually in negative words, not after a negation. So if someone say not bad, it will actually not be categorized there. It will actually be categorized here. We call it not bad. It's actually any negative words after a negation. Now, we also needed to disambiguate the negation, because we found that there were sometimes double negation, things that are not necessarily negative, or that don't change the valence of the word when it's preceded. And we found some of those, and we just listed a few. For example, not only, so I'm not only satisfied, I'm ecstatic. Okay, not only will not change, but not is there. Okay, nothing but wonderful. Okay, those are negation. And remember, because phrases will have precedence over words, if the software find no, but it followed by or not, and it's followed by only, then it won't be categorized as a negation. So now the software, when it will assess a rule, it will not categorize, it will not recognize this as a negation, but as something else. And since the rule only involves negation, that's what we will be able to do. So remember that rules, in this case, I had to create my rules outside of the negative words and positive words. Otherwise, the software will not be able to assess those rules. Okay. Now, rules also have another purpose that I think you should be aware of, is that sometimes it may be difficult to measure some concepts simply using phrases. And to give you an example, we were looking at an action in airline safety reports where pilots were disconnecting the autopilot. What we found is that there were pilots were using many words to make reference to the autopilot. It could be in one word, in two words, abbreviation AP as a single two-letter words, or A.P. to make, and so as an abbreviation. And there was also other terms, technical terms associated with the autopilot. And disconnecting was even more troubling because there was so many ways to measure the action of disconnecting, turn off, turning off, disconnected, was disconnected, and it was not necessarily before or after. So if in those situations, what we ended up, we created actually two categories. One for all the way one could express the concept of autopilot, and another one where we put all the verbs that could be associated with the action of disconnecting, turning off, or put off, etc. Okay, and we create a rule where we were looking at every sentence, and the sentence looked like something like that. Okay, so we had the target word, which was autopilot, and it was a category. Here I don't have it, but it was autopilot, for example. Let's assume that if it exists, near, and near would be either before or an after, disconnect. So here we could have maybe 10 entries, and here we may have 30 different entries. The thing is that the software was looking at those, and here, if it's in the same sentence, I may actually do and simply tell the software that they should appear in the same sentence, no matter the distance. But if you want to, or if you find that it should be close to a specifically to should not be long beyond a specific distance within the sentence, then you would use near instead. Okay, but and would work fine, and we'll so we were able to measure this connection, the connection between disconnecting and the autopilot. So we were able to measure an action this way. So this is actually another use of rules. Rules are actually much harder to develop. So we usually recommend that you start with phrases. And one thing that I should mention, well, first is that, and that's basically the reason why when you do an analysis, and here we have some categories, I typically suggest that you start with phrases, and the software will find those phrases, and it's quite easy because you simply have to drag them to the dictionary. So typically when someone builds a dictionary, what we suggest, after you explore with topic modeling or with clustering, you create your categories and try to categorize phrases first, because when you will apply the dictionary with phrases, you will have access to how phrases measure the concepts, but also the leftover words, so single words. And this is where you could add single words, knowing that single words may have more meanings. But for example, change, if I have some phrases that include the word change, what I'm seeing here, okay, 754, it's all of those that are not part of phrases, okay? So it allows me to see the words, the remaining words that have not been categorized. So those that are part of phrases will not be shown here. So if you have phrases that are quite explicit, that are less ambiguous, and that you had them, maybe some of the words will actually go down or even disappear from this list, which can be quite long, okay? So by doing that, by focusing first on phrases, you will reduce the chance that you will get false positive. But make sure that once you have developed your dictionary, before you do your final analysis and write your conclusions, and make sure that you do this keyword in context, and typically if it should be done on every single category if in your dictionary, to make sure that you are really measuring what you think you are measuring. Okay, so on that, I've tried to be fast, maybe too fast. So, but if you have some questions, I will try to answer those as much as I can. Okay.
Okay, thank you, Norma. If you have questions, go onto the right-hand side of your screen and please use the chat feature. So write in your question on the chat feature, and we'll try to get to them. One question, and you may have just covered this with the talk about phrases, but what if you have two different ideas in the same sentence? For example, you used the example of stress before. So if I can't stress enough how important it is to manage your everyday stress, how do you deal with that?
Okay, I'm not sure exactly. For example, what you mean by the two, but well, there are a few things with phrases that you should be aware. Well, first, some phrases will have two ideas, and it may not be the case here, but sometime, for example, if you do a phrase extraction and you have a phrase that really contains two different ideas, don't categorize those phrases. Focus on a single word. For example, this room was clean and comfortable. Clean and comfortable can come up quite often, but it contains two ideas, so you don't categorize that. Now, dealing with phrases that contain the same word that appear in the same word that appear from the same sentence, but that do contain that do carry two different meanings is more problematic. But if you are looking for distance, you have to look at whether a distance rather than a simple and Boolean operator like this word and this word in the same sentence. If you have those two phrases, it may be better to use a proximity rules that limit the search or the rules to a specific number of words, say within 3 words or within 4 words. But there's no analysis, there's no linguistic analysis done on the sentence to know whether those words are connected syntactically. It's simply a proximity rules that is being applied. So you have to look at that. But in a sense, if you have one phrases that mean that has a specific meaning, or a word that has a specific meaning, and a word in the same phrase that in the same sentence that have a different meaning, and if you're looking for one of those, it may not be that important to achieve disambiguation within this phrase, because you will have a match anyway, and the software will simply count the phrase, the sentence maybe twice. But if you can achieve disambiguation, then it will be possible. But the software itself, the rule will recognize if it has 2 words, it will assess both words and see whether each word match the rule that you define. Okay. So I'm not sure if I would have to probably see if a clear example where this would happen and where someone want to disambiguate in more detail one of those. Okay.
Okay. That's another question. If you've constructed a rule and you've got 80 that are good and say 20 that are not good, how do you know that your rule is constructed properly?
Yeah, rules are quite tricky to assess. The keyword in context that we have in WordStat does not necessarily will not necessarily give you an exact match of the rule. What you should do is that, okay, let me do it. Let me apply this dictionary, for example, up to the first level. And here I didn't I include everything. And what you would do typically, okay, the positive and negative are from rules, actually. And what you should do is do a keyword retrieval rather than a keyword in context. So here, when you right-click, you have access to both. The keyword retrieval will actually apply the rule. The keyword in context will actually look at all the items in your dictionary. So it may have more problems finding those items. But if you do the keyword retrieval, you'll be able to see. And the rules are somehow harder to disambiguate because you will have to look at the text. Well, here if it will take quite some time because we have 35,000 hits. But basically, the rule will be applied to either the paragraph or the sentence, and you'll be able to look at those, but it will not be like it was before, the word in the middle. It will be the word within the text itself, and you'll have to refine the rules in order to do that. So rules are much more difficult to disambiguate, so you have to be careful when you create them.
Okay, thank you. And one more question. Are there any, it's prefaced by this is a very involved topic. Are there any articles or books or reference materials that you would recommend to sort of look into this further?
Well, the first thing I would recommend looking at the reference that I gave you, if it is considered to be one of the best articles on how to disambiguate, and I will show you how to get to this article. I will go to our website because those authors created a dictionary, and if I go to the WordStat part and I select dictionaries, okay, I have to look for the forest value dictionary, and I click on that to learn more. And it is a dictionary that very well done. Even if you are not interested in values associated with forest, and this is the different categories that it contains, you should look at this article. And if you click on that, it will actually download the full report, which is a public report, and you could read that. And that would be my first recommendation. In terms of books, there are there are few books on content analysis, and well, and there's a few things on automatic word disambiguation. This is a full area of research, and this is not what we offer, but there's a lot of research being done in this area. But if you go there, you are looking for a machine learning type of solution, which I don't know any software that actually implemented, that commercial software that actually implemented that kind of disambiguation. So you will have to look more for content analysis books. Unfortunately, there's not a lot of those that I would recommend. If you look at Sage, at the Sage publication, they have maybe 3 or 4 books on content analysis. One of them by Nurendorf, I think it's called the content analysis code book, guidebook, or something like that. That could be a good reference. Maybe we can send you those reference. Weber, Weber did create a small book on content analysis. It's somehow out of date, but it's still useful because it does explain the keyword in context and a few things like that. And Krippendorf's Reader, I'm not a big fan of the book itself, the main book, but the Reader, which contain several good articles on content analysis, is also a good place to start to look at what is possible with content analysis, etc. And we could probably send you those 3 reference by email to all of those who participate. And in this Krippendorf Reader, content analysis reader, this article is actually, this report is actually republished simply because Krippendorf also recognized the fact that this is probably one of the best reference on how to build dictionaries. There have been books that have deal with that. Most of them are out of print, however. But we hope that maybe someone will catch up and will publish something that will be interesting. I know one person that has started to work on that. Hopefully, if he will be able to publish a article where we explain how to build dictionaries, and if we can, if this article is ever published, you can be sure that we will make an announcement on our website. Okay.
Okay, well, thank you very much, Norma. That's it for the questions. If anybody has any other questions or you think about it, think of some questions later on, please don't hesitate to send them to us. You can send them to us through support@fravalisresearch.com. So thank you for attending the webinar. Also, if there's a subject that you would like us to cover in future webinars, send it to us. Again, send it to us through support@fravalisresearch.com. And because we're always looking for ideas about what you would like us to cover. And please follow us on Twitter and Facebook and LinkedIn, or on our website, where we'll announce the dates and times of future webinars. We'll be having another one probably in the next 4 to 6 weeks. A recording of this webinar and the previous ones can be viewed on our website, and we'll also be sending everyone a recording of this particular webinar. So thank you very much for attending, and have a great rest of the day. Bye-bye.